Hello class, how are you guys doing? I'm constantly impressed by you. You keep just doing amazing things. We're getting to the point where we can start talking about the rest of the semester. We're beginning our last unit in networking, and this week is chapter 30, which is about multi-threading and parallel processing. We have one assignment that's an animation and our quiz. Then for next week, we'll be looking at networking. And we'll be making this chat program, so like an early instant messenger. So it should be fun. And again, another quiz. And then finally our last chapter. Our last chapter is chapter 32 about database information and working with Java. And because it is so horrendous to get everything downloaded and installed, we'll just be talking about that. So we won't actually have any assignments or projects for that unit. So along the same time, we'll be looking at our Unit 3 exam, and I'll be making that available for you. And then we'll go into our final. And your final is going to be a blackjack game. And because it seems that there's a blackjack game in Ravel, for your convenience, we need to change that up a little bit. So I'm thinking maybe a multiplayer networked blackjack game. I think that should be well within everybody's reasonable expectations. Now, if you notice, you're going to have several weeks to work on that, so it shouldn't be a problem as long as you pace yourself and don't put everything off till the end, because then it will be tough. Don't forget, there's some extra credit assignments at the end of the modules if you haven't explored and looked down there all the way. Some of these extra credit opportunities are not available this semester, like Join Skills USA, but some are available all the time, like attending a networking opportunity event. If you're a member of the CPU Club on Facebook, which it mentions in here, you can find out about all sorts of different events, and you could also use Meetup. So don't forget those opportunities are available. But you guys have all been working so hard this semester. I know everybody's grade is in pretty good shape. So let's get started looking at chapter 30, talking about multi-threading and parallel processing. When we look at parallel processing, we're thinking of units of work that are being processed kind of simultaneously by the processor. So if I run Task Manager on my computer, I see that I have a lot of tasks running. You can kind of take a look. All of these would be considered a task or a process on the machine. So I would call it Task Manager, but on Task Manager it calls it processes. So you'll see a little interchangeability with terms. Now in this screenshot, I've expanded PowerPoint, and you can see that PowerPoint has two sub-processes. Those are referred to as threads. And we could see lots of different definitions for threads. We might get down to the level of a very small command, where in this case I'm thinking of a thread being a different PowerPoint presentation that's open. So I could be doing things simultaneously with those two PowerPoints. So each of the threads is some sort of execution unit. When we're talking about multi-threading, we're talking about sharing the processor. In picture A here, this is out of your textbook, each thread has been allocated its own processor or its own processor core. So we see that the thread begins to execute and just executes to completion. In the second picture, in item B, we see that these three threads are all running on one processor, a single processor, so they're having to share the time available on the processor. That's called time sharing. And to us, it looks like these processors are running at the same time, but they're actually running concurrently, meaning thread 1 is going to get some processor time, then thread 2, then thread 3, then thread 1, etc. And we're going to split the processing time so that all three of these threads get to execute to completion. In Java, when we want to create threads, we use the runnable interface. So we can implement the runnable interface, and when we implement the runnable interface, we're going to create a runnable object, and then we're going to use a thread to facilitate the running of the task. So let's take a look at listing 30-1. Silly PowerPoint. So I think I have it open here, and you're going to find this listing on Ravel in Chapter 30, and Chapter 30 is not in the normal place in Ravel. Chapter 30 and beyond are considered web chapters, so when you're looking at Ravel, scroll down to find the extra material, and then in the extra material at the very bottom of that, you should see the web chapters. Now in 30-1, we have some different items, and I'm going to start at the end of this program. This is the whole listing that I got from the textbook. So at the end of this, we have a class named printNum. It implements the runnable interface. It has one class variable, lastNum, and in the constructor, it expects a number to be passed as a parameter, and it will use that number to initialize lastNum. Then we override the run method, which is required if we implement the runnable interface. And our run method actually says what pieces of code we want to run as this thread. So for this thread, we want to do a for loop. And in our for loop, we're going to run while I is less than the number that was passed to us, and we're just going to print out all these numbers. Okay? So pretty simple loop. We just want to do something that will simulate using the processor. So that's the printNum class. If we work our way up further from the bottom, you'll see we have another class that's very similar, printChar, and it's going to print a character. It also implements the runnable interface, has two class variables, one the character to print and one the number of times we want it printed. So in our constructor, we expect both of those parameters, and we use those parameters to initialize our class variables. Then in our run method, we are doing a for loop, and we're just printing out that character that they passed to us however many times they specified. Okay, so basically some pretty simple code, just some different for loops. They're just embedded in these run methods, which means they can be used to create threads. So now I'm going to look at our main, and in our main, we start out creating our runnable tasks. So our runnable tasks are going to be comprised of the printChar methods and printNum methods. Then we take those runnable tasks and create new threads utilizing those tasks. Then we start each of the threads. I'm going to go ahead and run this. And you should see that you're going to get some different results depending on how your processor was allocated. So mine started out printing some A's, and then it printed some numbers. And I'm going to go over. It looks like the printNum class got to complete, and then control was relinquished, and we got some A's and some B's. So I'm going to run that again. This time looks very different. We can see every time we run this program, we're going to get a different result because we're multiprocessing here. We're threading, and so we're running these statements basically concurrently, and each of them is going to get an opportunity to use the processor. So we'll see a little bit difference every time we run it. So pretty cool. So again, they're executing concurrently, and if we invoked run instead of start, the tasks would not be started in new threads. Let's try it. In our code, remember each of these classes implements the run method, so we could tell each of these threads to run their run method instead of using start. And what do you think you're going to see when we do this? Oh, we were right. First of all, we see our first task run to completion, then our second task printing out the B's, and finally our third task printing out the numbers. So we don't get any sort of multi-threading at all because we overrode our threading by using the run method directly. So we don't want to do that. We'll put those back to use start. Very good. So we still have our multi-threading application here. Now here's a little bit of code that they're asking you what's wrong. What is wrong with this thing? Well, there's a few things wrong. We basically are not happy with the way they're instantiating this task, and then we're trying to create a thread from this task. Can't really instantiate the task from within its own class or within its own method. If you noticed in our example, we have to make sure that things are happening in the right order. When we're working with the thread class gives us several different methods to use in controlling our threads. So we can use the start as we saw. A Boolean value is alive. We can set the priority. We can join this thread with another. We can make this thread sleep or yield to another thread. And finally, we can interrupt this thread's processing. So let's add a yield and a sleep to our program. If I look at our textbook, we'll see the code that they're concerned with so that we can add it to our program. Those are the what's wrong with these items. And continuing on. So yield is going to release control of the processor to another task. So I want to modify our run command of our print num, and we're just going to add this thread.yield statement after our print. So we want it to be within our while loop. I guess I can just type it. Ugh. So after I print out the number, I'm going to thread.yield. Now, when we look at the example, we don't need to pass a parameter, but we could if we wanted to. So let's try running this now and see how it works out. What we're doing basically is saying that every time we print out a number, we're going to yield the process. We're going to let somebody else have control of it. And sure enough, we see we printed a 1 and then we got some A's. So we shouldn't really see a lot of instances where our numbers print out together. We do right here. That means our other tasks or our other threads, we're not waiting to execute when we yielded. So we can see some difference there using our thread.yield. Now what about the sleep? When we sleep, we're basically going into a wait state, and so we can sleep for a number of milliseconds. And for this one, we're going to add this if statement in. So if our I is greater than or equal to 50, we're going to sleep for a millisecond. We're going to put this in our print char function because we've already updated our print num to do the yield. So if I is greater than, or do we say less than, equal? Doesn't matter, we're just experimenting. Less than or equal to 50, then I want to do thread dot sleep just for one. Now when we put that in, we receive an error. Our error says you could maybe expect an interrupt exception type, and you must be catching that or declaring it for this to work properly. So we need to enclose our loop within a try so that we can add a catch for that exception. So I'm going to try, and I want to end my try after the for loop. And I'll press tab to indent all that stuff. And I'm going to get my curly braces right. So this one goes with my for loop, and this one goes with my try. So then I want to catch that interrupt exception as EX. And if I catch it, I'm not really going to do anything with it. Now let me see what I've got wrong here. Oop, interrupted. Don't do that on your quiz. So we should be all good now. So anytime we want to use this sleep, we have to put it within a try catch, and we have to catch this interrupted exception. And if we think about this, we want our try to be outside of the loop, because if anything happens anywhere within this loop, we want to end it and catch that exception. So we're going to get a little warning here from NetBeans about that we have a sleep inside a loop, but that's okay. We know we do. That's why NetBeans is just giving us a warning. Okay, let's see what kind of changes we have to our output now. We see a couple of letters and then a bunch of our numbers. So just that 1 millisecond that we're sleeping is enough time for us to print out basically almost all of those 100 numbers. So when we did our yield then in our print num, there was nothing to yield to because our print char was still asleep. Okay, so some really good examples of doing some parallel processing, some thread handling at a basic level. Now, we'll be talking later about the join, where you can take a look at it in your textbook if we are not able to make a video for that. But when you join two threads, you're basically forcing one to wait on the other. So you're taking a multi-threaded environment and making it become single-threaded. When we're working with our threads, every thread is assigned a priority by the virtual machine. The thread inherits the priority from its spawner, and priorities range from 1 to 10. Now, if you're using the set priority or get priority methods, you want to make sure to use the thread class constants, min priority, norm priority, and max priority, and those will set the priority to 1, 5, and 10. And that way, if they ever change the priority system, it will be okay with your program because you'll already be using those constants. Now, if we have a really high priority thread, like this guy here, he can be controlling the processor. And if he doesn't issue any sort of waits, then the other threads can be left waiting forever for the processor and not getting an opportunity to run. So we could end up with a starving thread, and that's a thread that waits so long for the processor that it finally just times out and gives up. So we want to be careful when using priorities and make sure that we're releasing control of the processor periodically, not being a processor hog. When we don't use different priorities, like in a normal situation, we let the system kind of control it. And that really is good, because that way if we have system threads or something, they're going to, have the priority. But if in our Java environment, all of our threads have equal priority, each of the threads is going to receive equal processor time. And this is round robin scheduling. So in this picture, thread 1 is going to get a slice of processor time, then thread 2, then thread 3, and they're each going to get their own individual slice of processor time, the same amount of time. If we have one thread that never gets a chance to use the processor, that's suffering starvation, that is considered processor contention. We have too many demands on our processor, and we need our high priority processes to either sleep or yield to allow those other threads to complete. They're just running things into the ground. Let's look at the flashing text case study. In the flashing text, we're going to be looking at creating a Java FX application that uses threading, has some interesting code. Take a look at it here for you. So we start out extending our application, because again, we're going to be a Java FX application. We have a global string variable named text, and then we override the start method of the application class. We're creating a new stack pane, and we're going to set up a label that says programming is fun and add that to our pane. Now we're going to create a new thread. Notice it's an anonymous thread. We have not given it a name, and as a parameter to this thread, we're going to create the instance of that runnable class for this thread to use. Again, we're going to use an anonymous class. We're not naming it. So after we have new runnable, we see the opening curly braces. This is our actual runnable method. So here's our run method. We're enclosing it within that curly brace. And in our run method, we've got our try, and we're going to go into an endless loop while true. We're going to be checking the label text. If the text is empty, we're going to make it say welcome. Otherwise, we're going to make it empty. Then we're using the run later command. Take a look at your book, get a little bit more familiar with that. But we're basically saying that every time you get a chance, run this runnable, and this runnable's run method says, I want you to set the text property of the label text equal to my text string. So some embedded methods. So right here at this closing parenthesis is the end of our parameter string for this run later runnable. So notice how that syntax works. Then we're going to tell the thread to sleep to our catch, and right here is the end of our first runnable instance. Again, we're saying run the start method of that class, because remember, we were in effect creating a new thread. So we want to do thread.start. Then we're going to set up our scene and our stage and do all of those kinds of normal things. So let's run it. Now this is just like the example that you had earlier in the semester when you were working with animation, except that now we have it working using threads. And that's what you need to do with the assignment for this week. So please take a look at that. Notice you have the odd numbered assignment so that you can look at the even numbered assignment that closely correlates to that as an example. As always, let me know if you have any questions, but I think you should be well on your way to create this first application that's due for this week. I'd like for you to plan on us talking a little bit more about parallel processing, and I'll get a video to you about that when I can. In the meantime, let me know if you have any questions.